Okay, we're about ready to start our last lecture for the chapter. We will be including both sections 5.9 and 5.10. If you notice, they both were called linear programming. One was called linear programming 1, the other one linear programming 2. So we will be using all the topics we used in the chapter, so it culminates into these big problems called linear programming, where you show all your stuff from the whole year, or from the whole chapter. Year would be a bit too much. So, recognize properties of systems. We've been using those all chapter. They're still going to be huge. You've got to graph inequalities, and from there you're going to pull some things together for a real-world problem. And in 5.10, same thing, more real-world stuff. But the big difference really is that in section 5.9, they will give you more information. They will give you the inequalities. They may even do the graph for you or start the graph, but you will have to do some of the graph. Whereas in 5.10, they will give you nothing but a paragraph. It looks like English, and you will have to translate it and do everything, the graphing, etc. So let's find out what that everything is. And that's what this lecture is really about. Just it gets down some steps of some things you're going to be doing. So here is my list, and then when we get to class, we'll be doing one example together in detail to show you how it really flows, and then you'll be on your own with some work time. So starting with the first 3 steps are what we've been doing so far throughout the chapter. We identified the variables, usually x and y. We translate any words into a system of equations. We've been dealing usually with 2, but now I can say we're probably going to have 4 minimally. 4 different inequalities we will use to help graph a situation. So these situations are going to be a little more complicated. They're going to be real life, as we have already said. When you graph the system, you want to make sure you find the x and y intercepts for all your equations. So remember, your y-intercept shortcut is c over b. Your x-intercept shortcut is c over a. You will definitely want to use both of those as you graph. Use solid or dotted lines as you graph, depending upon your inequality signs. We should know that a solid is your less than or equal to or greater than or equal to, and a dotted or dashed is your less than or just greater than. Shade accordingly also, and then find the vertex points exactly, and we talked about this in the last section. In most cases, you're probably going to use linear combination, which we call elimination, or substitution. One of our other methods that we learned in the chapter. Once you have that part down, and that's key, obviously if you miss something there, you get something wrong there, we've got a problem. Because the next part will be where the real world comes in. Most times in business, you are talking about one of 2 things. You want to maximize your profits, and you want to minimize your costs to be the best in business you possibly can. Keep your costs down so you can keep your profits up. Most of the problems will be one or the other. We want to maximize profits, minimize costs. They will tell you in the beginning, you can't have one of each. This equation or this information should be put off to the side. So if it's a profit equation and you know it's 5s plus 2y or whatever your equations are or variables are, leave that off to the side. Do not include it in this system up here, because if you do, that'll really screw up the rest of the work part. So once you have that profit equation or that cost equation, you will be substituting your vertex points, and that would be the exact vertex points, into it to make some determinations. Obviously with profit, we want to maximize a profit. With costs, we want to minimize our costs. And when we find that minimized or maximized amount, that will be our result. So our result could go 2 ways. It could be, for profit, we want to be looking at the largest possibility. And then for cost, we want to be looking at the smallest possibility. And again, it'll be a little more clear as we work through a problem in class together. But for the time being, those are some of the good notes. Those are the steps you want to use in your programming as we go through it. That will be what we talk about, and that will I will be expecting you to follow as we go to class.